Section 7.4 and 7.5 in our pre-calculus textbook deal with solving trig equations. But before we actually get into the solving of the trig equations, we're going to do a little review of solving quadratic equations. Alright, there were a few different ways you could solve quadratic equations. I mean, of course, you could solve them by a calculator, right? By graphing or by using a table of values on a calculator. But then the algebraic methods of solving were first by factoring, right? So what you would do is you would use this thing that we called the zero product property, which pretty much said that if you have two or more factors that multiply to zero, right, you know that at least one of the factors has to be equal to zero. So that's what we used to solve quadratic equations by factoring. We would factor them and then use the zero product property. Alright. Now the problem was, of course, not all quadratic equations would factor, so the ones that didn't factor we would have to solve by the quadratic formula. And remember, the quadratic formula, to use it, you have to first get the quadratic equation in that form, ax squared plus bx plus c equals 0. And just, as a side note, of course, you also have to get it in that form if you're going to solve by factoring, right? Because if you're going to use the zero product property, the equation has to be first set equal to 0. But the same thing applies when you're solving by quadratic formula. You have to first set it equal to 0, and then the solutions are going to be obtained by using that formula, which of course is known as the quadratic formula. Alright, so what you can see here in this activity here, 7.4, is that every equation on the left is just a strictly quadratic equation, right? Using just x mainly as the variable. Yeah, I guess always x, right? All the equations on the left just use x. Well, there's one, number 9, that has an x and a y in it. But it's just, single variables, single letters as your variables. Whereas on the right, you have pretty much a similar equation, only the variables get replaced with trig functions. So like the difference between 9 and 10 is that in 9 you have an x, and then in 10 that gets replaced with sine of x. And then you have a y also in 9, but then that gets replaced with the cosine of x in 10. And if you look at the left and right hand side of all those equations, they're all going to be the same idea, right? So on the left you just have an algebra problem. On the right you actually have an algebra and a trig problem. Okay, so what we'll do here is we'll focus just on the algebra ones. Okay, so now number 1 here, this one is probably the easiest one of all. Why? Because it's already factored, right? You have two factors here and they multiply to 0. So all you have to do is apply your zero product property immediately and just take each factor and set each factor x minus 1 equal to 0 and 2x plus the square root of 2 equals 0. You just set the two factors equal to 0 and then you just solve. So in this case you're going to get x equal 1, and in this case you're going to get x equal negative radical 2 over 2. Right? So that was just direct application of zero product property. Now 3, it's not factored, right? So what I would do with 3 is I would try to factor, and this was the most basic type of factoring, called factoring by the GCF, right? And what is the GCF? The greatest common factor, which basically means what's the biggest thing that will go into both of those terms. Well, they both have an x, so I can take that out as part of my common factor. And then also, what's the biggest number that'll go into both 3 and 18? Well, 3 goes into 18, so the GCF here is going to be 3x, right? So that's your GCF. And then once you factor out your GCF, you open a parenthesis, and then what goes inside the parenthesis is whatever's left after you divide out the GCF. So what you're really doing is you're doing 3x squared divided by 3x. When you divide the 3x out, you're left with x. And then when you divide 18x by 3x, you're left with 6. And now this just reverts to problem number 1, right? Which is now zero product property. I have two things multiplied to 0, so I know that either 3x equals 0 or x plus 6 equals 0. So from this one I'm going to get that x equals 0, and from this one I'm going to get that x equals negative 6. So there's my solutions to that one. Right? That was just factoring by the GCF. Okay. Now 5 is actually a strange looking problem. In 5 I can see people making a little bit of a mistake here possibly, because they might say, oh, alright, well I can just divide out an x on both sides. No, you can't. Right? Just in general, you never want to divide an equation by a variable, because the problem with that, of course, is the variable could be 0, and dividing by 0 is undefined. So you cannot divide by the variable. So what you got to do here is set it up to use the zero product property. So you've got to set it equal to 0 first. And how do you set it equal to 0? You just subtract an x. So you would end up with x squared minus x equals 0. And now it's a very simple problem. Right now it's just a GCF. Both of those terms contain an x, so I can take out an x, and I'm left with x minus 1 equals 0. And then I just use my zero product property, so I have x equals 0 or x minus 1 equals 0. So I end up with x equals 0 or x equals 1. Right? And now 7 was a little bit harder because, sure, it's already set equal to 0, but this is one of my ones that I would call an ax squared plus bx plus c trinomial, right? And there's no common factor, so I can't factor anything out that will go into all three of the terms. So if you recall, this thing had to factor into two binomials if it was going to factor at all, right? If it's going to factor, it's got to factor into two binomials. Okay? And what I need is I need two terms that'll multiply to 2x squared, and then I need another two terms that will multiply to the 3. Right? So what's going to multiply to 2x squared? Well, there's only one possibility, right? 2x times x. Those are the only two things that are going to multiply to 2x squared. And then what are two terms that'll multiply to positive 3? Well, either positive 3 and positive 1, or negative 3 and negative 1. And now this is where what the middle term is important, because the middle term being negative, what that tells me is if I'm going to have things that multiply to a positive but add to a negative, that means they both have to be negatives. So the only possibility here would be a negative 1 and a negative 3. Now, do I know that this works? No, I'm not 100% sure. So now how do I check it? I just multiply it out to check it. So really what all I have to do to check it is do the O and I of FOIL, right? What I call the OI of FOIL. And what is the OI of FOIL? There's the O, which is negative 6x, and there's the I, which is negative 1x. So that does indeed add up to negative 7x. So that's the proper factorization of 2x squared minus 7x plus 3. And now, again, it's just zero product property, right? I have two factors here that multiply to 0, so I can just set each factor, 2x minus 1 and x minus 3, both equal to 0. So I'm going to get two solutions here. x equals 1/2 or x equals 3. And of course that would be my solution. Right? Now there is another method of factoring those ax squared plus bx plus c trinomials, which I call the AC method, which I use generally when there's more possibilities. But the reason that I just did what's called the guess and check method here is because there were a very limited number of possibilities, right? There was only one way to get 2x squared. It had to be 2x and x, and there was only one way to get 3 really, right? It had to be a -1 and a -3 because the middle added up to a negative. So that was one that I would definitely recommend doing a guess and check on. All right. So now we've reached the one that I talked about before that has the 2 variables. But again, just because it has 2 variables doesn't make it any different than the other ones. It's the same process. What can I do here? I can factor out a GCF. Both of these terms actually contain the y, right? You can see the blue in both of them. So I could take out a y, and then when I take out that y, what's left is 5x plus 4 equals 0. And it's still the same thing. It's still the zero product property. I have 2 factors multiplying to 0, so I know that either the first factor, which is y, equals 0, or the second factor, which is 5x plus 4, equals 0. So y equals 0 is done, and then this one would become x equals -4/5. So there's your solutions. Y equals 0, x equals -4/5. So the only reason that one was a little bit different is because it had the 2 variables, but otherwise it was just GCF problem.